Hello everyone, welcome back to the channel. Today we are going to build something super useful. We will download real text from the web, process it with LlamaIndex, and then generate some embeddings using Hugging Face models. Why does this matter? Well, embeddings are the backbone of AI-powered apps like semantic search engines, recommendation system, and chatbots. By the end of this tutorial, you will know how to take a raw text, transform it into machine understandable vectors, and set the foundation for smarter application. You have to install some libraries, and these are LlamaIndex, LlamaIndex Embeddings HuggingFace, Sentence Transformations, and Request. Before we jump into the code, I'll just show you the flow of this tutorial. We'll download the text from online, wrap that text into LlamaIndex Document, generate embeddings using Hugging Face, and we'll explore those embeddings. Let's import libraries now. First, I'm going to import request. Then from LlamaIndex.core, import document to convert our text into document format that LlamaIndex uses. Then vector store index to convert this into index. Then from LlamaIndex dot embeddings dot hugging face, import hugging face embedding. Let us execute our code. We'll use request to fetch online text, wrap it into document for LlamaIndex, and then process embeddings with Hugging Face. Now to download the text, I'm going to make one variable URL, and then I will give the URL name here, https www.gutenberg.org/files/11-0-txt. I hope this should work. Now I will save this in a variable response after calling request module and then the function get URL. And once I have it here, I will extract the text data from there and save it in the variable text data. So I will write here response.text, and now let's see text underscore data. At this point, we should get the entire book stored inside the text data. So this is a book here in this URL, and let's execute our code. Name error, request is not defined, so it is not a request. I have to write here s, and now let us execute our code. So we see the book here, start of the project Gutenberg ebook 11, and even you can just copy this URL from here, go to the browser, paste it, and you can see it yourself. So this is the book. These are the chapters, chapter 1, 2, 3, and so on. We have downloaded this entire book here. Now the next step is, so this is in the text format. If you type here type of text underscore data, it is string. But when you want to process it with LlamaIndex, you have to convert this text into document using the document function. Now I'm going to make one variable document here, and then I will call this document class that I already imported above, and it has the parameter text where I'm going to pass this text data here, and then I can just print this document. Now here you will see the difference. Here if you look at the original text, so it starts from here, start of the project Gutenberg and so on, but here you will see it has now converted into document, and it has got some ID here, embedding is none, metadata, and so on. Now this is in the format that LlamaIndex can use. This steps converts the raw text into a LlamaIndex document, which is the standard format for working with data inside LlamaIndex. Now what we have to do, we have to convert this text into embeddings, that is number. First of all, I am going to import this HuggingFace embedding model. I will make a variable embedding underscore model. Then I will call HuggingFace embedding, and the parameter name is model underscore name, and here I am going to use BAAI slash BGE small English EN, then version 1.5, and here I will complete the code, and I can then just print this embedding model. Now this is a small size of embedding model that you can use for small tasks. Here we are just picking this embedding model. It is small, fast, and excellent for semantic similarity tasks. Of course, you can try other Hugging Face model later depending on your project, but here we are using this one. Now the next step is to build a vector index. First I am going to make one variable index here. Then I will call this vector store index class that I already imported. From this I will call the method from documents, and now inside this I am going to pass this document that I converted here. Let me show you this one. Inside the list I will write here document, and then I want to convert this into number by using this embedding model. So I will pass this embedding model here, embed underscore model, this is the parameter, and I will pass embedding model, this one that we are going to use, and I can also print this index. Now this is the you can say it's a magic step. The text is automatically chunked. It will automatically create chunk. Now I got some error here. Let me just check. Could not load up in if you are using to no API key found. Consider using embed model is equal to local. Okay, I have already passed this here, and I should not get an error from documents. Then this is the okay, I made a mistake here. I have to write just embed model. Okay, now let us execute this code again. This time we should not get any error. Let's wait. You see it is still working. Yeah, now it has converted into this index. What is happening here is the text is automatically chunked, that is break into pieces. Each chunk gets converted into an embedding vector. Finally, a vector index is built, which is like a searchable knowledge base. All these steps are working in this vector store index dot from documents. Now let's come to the last point. We just want to explore the embeddings that we have created for this text, and for that I'm going to write a print statement. Let's look at the original first. Print text underscore data, and we are just going to see some 300 words here. So this is the original text from this text data, and now let's look at the embeddings for this text. I will write here print and then embedding model, dot get text, get underscore text underscore embedding, and then I will say this text underscore data for the first 300 to 8. Now let us look at the code. Okay, incomplete input. Yeah, I have to close one more bracket here. Okay, here you can see I got numbers here, so these are the embedding. The first print shows the actual snippet of text, the opening of Alice in the Wonderland, and the second print, this shows the embedding vector, which is just a list of numbers. Each number encodes some hidden semantic meaning from the text, and together they form a unique fingerprint for that piece of text. Why does it matter? So similar text will have similar embeddings. That means we can use embedding to build semantic search engines, question answering system, chatbots, and recommendation tools. For example, a chatbot could search these embeddings to find relevant passages, or a search engine could instantly retrieve the most meaningful text, not just keyword matches. Now let's look at the final wrap up. So in just a few lines of Python, you downloaded real world text data, converted into a LlamaIndex document, generated embeddings with Hugging Face, and built a vector index ready for AI powered search for chatbots. You can try experimenting with your own text files or websites and swap in different Hugging Face model to see how result changes. If you found this video helpful, don't forget to hit like, share, and subscribe for more LlamaIndex tutorials and AI coding guides. Thank you again for watching.